Hi and Assalamualaikum warahmatullahi wabarakatuh. We are from group Creative Thinkers. Will present to you our group project. So we decided to choose the logical connective topics. My group members and I will explain what is the logical connective and show some example for these topics.
Assalamualaikum. My name is Huda Akila binti Edi Azhar. My matric number is 2020458122.
Hello and hi, Assalamualaikum. My name is Nur Habibah Maisarah binti Muhammad Nur and my matric number is 20206-20146.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Ain Hazwani binti Muhammad Nazri and my matrix number is 20208492.
My name is Cikgu Nurul Adila binti Cikgu Syakuri and my matric number is 20206262.
So what is logical connective? Okay. A simple statement will consist only a statement, which is one subject and one predicate. It is also known as primary statement. A few primary statements can be combined to form a compound statement, which is by using logical connective. So logical connective is a symbol which is used to connect two or more propositional or predicate logics in such a manner that resultant logics depends only on the input logics and the meaning of the connective used.
So firstly, let's take a look at logical connectives. We have 5 different logical connectives with its symbols and statement. So firstly, conjunction, its symbols and we call it as AND. For disjunction, we call it as OR. And for negation, we have 2 different symbols and the statement is not. For conditional or implication, we have the symbol implies and the statement is if then. So for biconditional, we have the symbol biconditional symbols and the statement is if and only if. So to further see the conditional and implication, we say it as P implies Q. Or alternatively, we can call it as P is sufficient for Q, P is sufficient condition for Q, Q is necessary for P, Q is necessary condition for P, and P only if Q. So next, let's take a look at logical connective and its definition. So first, for not P, its definition is the negation of statement P, which the opposite of P. For P and Q, the definition is if P is true and Q is true, then P and Q is true, otherwise P and Q is false. For P or Q, if P is true or Q is true, or both P and Q are true, then P or Q is true, otherwise P or Q is false. For P implies Q, if P is true then Q is false, then P implies Q is false, otherwise P implies Q is true. For P biconditional Q, if P and Q give the same truth value, then P biconditional Q is false. Next is the truth table. So as we can see, we have for the first row, we have P, which true, true, false, false. For Q, we have false, false, true, true. For the negation of not P, which the opposite of P is false, false, true, true. For conjunction, for P and Q is true, false, false, false. For disjunction, P or Q is true, 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 false. For conditional, P implies Q is true, false, true, true. And for biconditional P, biconditional Q is true, false, false, and true.
Okay, now I would like to present some examples that relate with our topic, which is logical connective. Okay, let's get started with example 1. Okay, now I would like to put 3 alphabet with different situation, which is P for Zikri plays football today, Q, Zikri woke up early, and R for Zikri finished his homework. Okay, now we look at the statement and the symbol that relate with each statement in different situation. Okay, first is Zikri does not play football today and he finished his homework. So we have put the symbol is not P and R. Okay, next. If Zikri finished his homework, then he woke up early. So the symbol is R implies Q. Okay, next. Zikri is not woke up early and he does not finish his homework. So the symbol is Zikri is not woke up early for not Q and he does not finish his homework is not R. Okay, next. Zikri finished his homework if and only if he woke up early and play football today. So the symbol is R by conditional with bracket Q and P. Okay, the last one is it is not true that if Zikri woke up early, then he does not go to play football today. So the symbol is not or negate in bracket Q implies not P. It is not true relate to the not or negation. Okay, next we move on to example 2. Okay, the statement is P and Q in bracket implies R in square bracket or P by conditional with R. Okay, now we have to do the truth table to show that it is tautology or contradiction or contingency. Okay, first we have to do the table and put the symbols to get the last compound statement. Okay, first we have to put P, Q, and R. P, true, 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 false, 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 false. And Q, true, true, false, false, true, true, false, false. And R, true, false, true, false, true, false, and true, false. Okay, next we move on to the P and Q. We have to look at to the symbol P and Q. So if P true and Q true, the statement P and Q is true. And if P and Q have one false, so the statement is false. Okay, next we go to P and Q in bracket implies R. So if P and Q true and R false, the result is false. If not, the result is true. Okay, next, P by conditional R. If P and R true true or false false, the result is true. But if P and R are different, true or false, the result is false. Okay, the last one is in bracket P and Q implies R is square bracket or P by conditional R. So we have to look at the first statement or P by conditional with R. So the result is true, false, true, 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 true. Okay, now since the compound statement is not tautology, not true all the result, and not contradiction, the result not false, all false, and therefore there is contingency.
Next, I will proceed with the example 3. So here are the 5 primitive statements in this example. We denoted P for Mary spends more time on her training. Q, she can improve her skill in netball. R, Mary's father buy her a pair of new shoes. Mary's father buy a new shirt. And T, Mary will be happy. So from these primitive statements, we will make some new statements. Okay, the first statement is, if Mary spends more time on her training, then she will improve her skill in netball. Okay, for the second, if she can improve her skill in netball, then her father will buy her a pair of shoes or a new shirt. Statement 3, Mary will be happy if and only if her father buy her a pair of shoes. For the statement 4, she cannot improve her skills in netball, and her father did not buy her a pair of shoes nor a new shirt. Statement 5, Mary is sad. Okay, for the first statement, we will write as P implies Q. For the second statement, we will write as Q implies in bracket R or T. The third one is S by conditional R. For the statement 4, we will write as not Q and in bracket not R or not T. And for the last statement, we will write as not S. Okay, so we finish with the example 3. Now let's proceed to the example 4. Okay, for this example, I will show you how to construct a truth table. Okay, the statement is in bracket P implies Q and in bracket Q implies R, close bracket, implies in bracket P implies R. Okay, from this statement, we can see that we have three prepositions, which is P, Q, and R. So here are the tips on how to construct a truth table for the three prepositions. Okay, so each of the preposition will have two truth value, which is true, T, or false, F. The preposition P, where the first four line, we will write T, and then for the last four, we have to write F. Then for Q, we will write 2 times alternate T and F, which is T, T, F, F, T, T, F, F. And for the preposition R, we will write alternately T and F, TF, 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 TF. After we fill in all the truth value of preposition P, Q, and R, then we will find the outcomes of each of the input variable in this statement. For P implies Q, the result is TT, FF, TT, TT. For Q implies R, the result is TF, TTT, FTT. For in bracket P implies Q and in bracket Q implies R, the result will be TFFF, TFTT. For P implies R, the result will be TF, TF, TT, TT. Okay, for the last column, we will get all true for all possible outcomes. So we can make a conclusion that this statement is tautology. That's it for the examples.
In conclusion, we use symbols to stand for the relationships between statements. This is to indicate the form of an argument. These relationships are made possible by logical connective such as conjunction, for and, disjunction, for or, negation, for not, and conditional for if, then. Connective are used in compound statements, which is one of each is composed at least two simple statements. That's all from our group. Thank you for watching this video until the end. Thank you.